is now my pleasure to introduce Steve Meuse, who will be presenting Embedded CDN in 2023, a status. Steve is a solutions architect at Kentik and a former NANOG program committee member. He is no stranger to the NANOG stage. Steve is coming to you today from California. Welcome back, Steve. It's a pleasure to have you. Boston, Massachusetts. Yes, he's from Massachusetts. I apologize.
Well, welcome, everybody. Can you hear me? 1, 2. Can you hear me? Okay, there we go. So again, my name is Steve Meuse. I work in the solutions engineering team at Kentik. The talk I'm going to give you to today is originally written by my coworker, Nina Bergeson, who probably many of you know. Nina gave a presentation to NANOG 2012 timeframe. At the time, she was working for a telco, Tele Denmark in Denmark. And from her perspective, she was being, having to deal with at that point in time in 2012, an influx of new embedded cache vendors. So meaning, the Facebooks, Googles of the world, building caches and wanting to deploy them into telco networks. And from her perspective, each one of these embedded cache systems is a little bit of a snowflake. And so her presentation was really talking to the community and specifically the vendors to say, look, from an operator perspective, make this easier for me. So what this presentation is we're going to talk about what an embedded cache is, what CDNs are and all that stuff, which I'm sure most of you know, but we'll talk about it a little bit more in detail. And kind of at the end of it, take a look to see where we are, how much has changed since 2012 to now. Are things better? Are they different? Or are they the same? So of course, what is a CDN? I think we all know what this is, but on the most high level, it's a bunch of servers out in the network. It's a method to get, content onto those servers. And then it's basically a way to deliver efficiently deliver or steer the traffic from the servers out to the eyeballs. Now, when we're talking about embedded caches, we're talking about service provider networks, specifically eyeball networks, who have these caches dug into their network and the methods for you steering that traffic from those embedded servers within the service provider networks out to the eyeballs. So the CDN market is not new. I think Akamai sort of being a leader there started probably circa 99, 2000 timeframe, somewhere around there. So it's not exactly new. There are sort of a lot of the players that have been around for quite a while, Akamai, Lumen, Tata, Edgio, well-established and reliable and all have very global reach. Then there's this slightly sort of newer generation of CDNs like Cloudflare and Fastly and StackPath and others, and who maybe offer a slightly different set of services for different content delivery types and so forth. And there's a lot of overlap in terms of services depending on what they want to actually be able to deliver. And I think the point here is that the actual large content owners end up quite often using a spread of these CDNs depending on geographic reach. So, one CDN might be better placed in South America or Asia Pac. So the actual content owners are going to end up spreading their content across multiple CDNs to get as best reach as possible. Now, what happened sort of the 2012 timeframe is that the largest of these over-the-top services started building their own networks and realized that the level of traffic that they had to deliver was just so great that they actually needed to really build their own actual content delivery. Netflix, of course, is one of the biggest. But Apple, Microsoft, Amazon, Facebook, Google, the usual suspects that you might see. But as they found out, building a CDN on a global scale is no small task. It's quite an undertaking. So really only the largest of these over-the-top services are really willing to undertake that kind of large task. And then sort of in the modern world, as the cloud world started to develop, most cloud providers have their own CDN that can front end the cloud services as well. And it's all kind of overlapping now. So You have services within a cloud provider that has its own embedded caches, but then the cloud has its own cache too, so or own CDN too, so it can get very, very cloudy, as you might say. So who are some of the players that you might see in the market? Usual suspects you might see. Most are probably sitting in the audience or here at the conference at some time. Akamai, Netflix, Google, Amazon. Some of the newer players that we're seeing into the market are folks like CDN 77, Quilt, who has been around for a while but is sort of relaunching themselves, and then there's more people coming as well. And we'll talk a little bit about this in some specific markets. So if we start digging into the stats a little bit, there's a really good study that was performed by some smart folks, Lefteris, who's here this week. And they presented effectively that there is roughly 3,500 different ASNs globally that have embedded caches within them, which is a rather surprising number to me. When I saw that, I was actually quite shocked. So working at Kentik, we obviously have a lot of service provider customers that were able to use some of anonymized data to look at statistics from them. It is a relatively small sample set. When Kentik originally started, our privacy policy was that we would not share data with anyone. But eventually we have developed an opt-in program. So a lot of service providers had started sharing the data with us so that we can make these presentations available. So from the market, from the small data set that we're working with, these are the top 6 that we're seeing. So Google, Netflix, Facebook, and Akamai. Those are the 4 primary that we see in most locations. But then Apple and CDN 77, surprisingly, are starting to pop up more. And if you look at the pie chart on the right-hand side there, you can see that there are a number of others, but they increasingly have smaller and smaller reach. And again, this is from a relatively small sample set, but it's worth interesting to see. So one note that as I was kind of browsing the data set and looking specifically, sort of generically at a lot of our Latin American customers, is that there is a greater number of unique numbers of embedded cache vendors in the Latin American market. And I was kind of curious, like, why is it? I don't have any specific answers, but is it because there's a higher cost to deliver bits to that generic region? Is transit costs just that much higher in Latin America that it would force people to invest more into embedded caches? Maybe. Another one that we kind of talked about internally too is that specifically in the Brazilian market, where there's a lot of service provider networks, they don't have the baggage of legacy video services to deal with. So if they want to offer video services, they're going to be doing IP set-top boxes, over-the-top video services, and that would probably drive a lot more activity for the embedded cache market and other logistical challenges for just dealing with up-and-coming markets. So I'm kind of curious at the end if anyone's seeing similar type of penetration in the Latin American market, let me know. So if we look at the caches that we have access to, the data for the caches anyways, and if we specifically filter the traffic to just CDN source traffic, which of course still counts for 90+% of all traffic to these customers, we're still seeing, even though they have embedded caches, 74% of their traffic is still coming in over the external network border. So that would be IX ports, transit ports, peering ports. And roughly 14% coming off of those embedded caches into the customer base. Now, again, this is a relatively small sample set, and that number can vary greatly customer to customer depending on their policy on embedded caches. If you take the biggest, I'll use the North American market as an example, or the American market specifically, the largest of the cable companies, and DSL providers, fiber providers, some of them don't actually want to have caches embedded internally in their network for various number of reasons, both technical and political. So, a lot of that is not necessarily surprising that 74% is still coming in over the border if we aggregate this data together. So just understand that. On an individual provider level, it could be much, much higher, coming directly from the caches. So generically speaking, roughly 7% would be, caches filling other caches within the network, and then some smaller percentage of caches filling externally to other caches off net somewhere else. And this was about a week's worth of data, so it included a Sunday night to capture the big video traffic. So this gets kind of interesting. So if we take the, again, relatively small data set, and we kind of look at the various networks and look at where the traffic is coming from and going to, it's interesting to see the variance. The first thing that sticks out, if we start with the second one, Netflix here, 72% of the traffic to these particular customer base, coming in from the embedded servers directly to the customer eyeballs. Netflix is somewhat unique out of these four vendors in that their content is a bit more static. They have a defined library of content to view. So it's probably a lot more cacheable, and with advances in the hardware stack, being able to serve more of that directly off of the caches, an entire library's worth of videos. But they still will have some outside to the end users directly that still might be the long tail of their library that get fed from mid-tier caches and so forth. And then smaller stats for embedded and cache to cache and so forth. Google and Facebook are much more similar in terms of how they're actually delivering. They have some number of, some amount of their content is cacheable and can be delivered from those caches. So in the case of Facebook, roughly they're almost the same, 54 and 56%. And, roughly 40-ish% from outside back to the eyeballs, again, from mid-level to caches and so forth. And then Akamai. Now, you might be tempted to look at this and say, okay, Akamai's efficiency is less than the other providers. This is a result of our relatively small data set, unfortunately. A handful of the customers that we happen to be using in this data set were having capacity issues off of their Akamai clusters, so they didn't have the ability to serve 100% of that traffic. If I survey our customer base kind of on a more global scale, we see that number to be probably similar to Google and Facebook, closer to 50% coming directly off the caches as a rough number. And we'll talk about this a little bit, but every network's unique. We see a lot of, some network might have a much higher percentage delivery off of their caches, others not so much, and there's a number of factors that go into this. So, when Nina was talking about her original problem set back in 2012, there was a crash course from the provider side of learning to deal with all the data that goes into figuring out how to steer the traffic to the end eyeballs. So in almost all cases, BGP is involved. Each service provider has to signal the prefixes they want served to the individual caches. There's a lot of information here, but you can see, the caches need to be consistent in terms of the prefix they're given. The sessions all need to be fairly identical, and the prefixes sent from the service provider are only the prefixes that they want served from that cache, generally speaking. But of course, DNS is a major part of this as well. The requesting resolver from the service provider network is used as a way to steer the traffic back in. Anycast, can be used as well to steer, and of course, geolocation. And reality is that each one of these networks uses some portion or all of these. So there's no common method, which was one of her complaints originally. Not really complaints, but really more sort of like frustration points of that. It was hard from an operator perspective to have to understand the entire ecosystem for each one of these to be able to efficiently steer the traffic around. So this is fairly simplistic, just saying, I'm announcing this prefix to this cache. I want to go get a movie. The cache responds and says, go to this movie. This is all fairly standard stuff here. Same for DNS. In this case, the end user goes to movie.com or whatever and says, I want to watch a movie. They figure out the resolver server is located off of this closest cache. So the DNS response is site.com.cdn something. And that user is then redirected to pull the movie off of that cache that's close by. And this is all fairly standard stuff. And then all the other stuff. This is the magic that happens behind each one of the CDNs, all the other data sets that they use to try to help steer the traffic around. Latency, QoS data, load data. If a particular server is loaded, you obviously don't want to serve content off of that one particular load. There's some concern about how storage is distributed within the clusters and so on. And not all content is on all clusters and all servers and so forth. So there's a lot of magic that happens in the back end to try to steer this around too. And I don't pretend to know all of the ins and outs. So we just want to point out that when you're trying to troubleshoot all this, it's not just is DNS working or is BGP working the way you expect. There's a lot of other magic that happens. So if we start taking a look at the traffic profiles in a little bit more detail, we start to take a look at a chart here. This is kind of what we see typical deployment for a Netflix traffic profile. So the vast majority being served off of the caches with that's the big blue number there. And let's see does this laser pointer work? It's kind of hard to see here. The green number, the green line there would be the data that's served from the mid-tier or beyond cache. And Netflix, of course, has a very specific fill window. So they're filling the caches at the peak or at the trough at the middle of the night so that they're utilizing the bandwidth efficiently. And it's a very defined window of time. It gives them plenty of time, the scale that they work at, they can compute a day's worth of statistics and say, what is the most popular content that's not on the server and we need to push down onto that server or cluster of servers. This is more of like an Akamai cache profile. Again, vast majority still coming from caches, but now you can see due to the number and the varied type of content that they have, it's much harder to deliver their really extremely broad set of services off of a single set of caches. So you see a bit more in the green there, you see a bit more of the pulling off of other caches, mid-tier, mid-fill, whatever you want to call it. And then the gold line here, or the yellow line here, is the cache fill pattern. So you can see as compared to, if we back up to, if we back up to like a typical Netflix deployment where their cache fill is happening at a very specific window in the middle of the night, Akamai is much more flat and throughout the entire course of the day. So I think that's interesting to see the difference between how it's pulling from mid-tier and the fill pattern versus the continual cache fill like that. And then the Facebook, Facebook/Google type of profile, somewhere in between. Still a lot coming in, still pulling some amount from the mid-tier caches, but the cache fill is a bit more dynamic. And not everything, of course, in these services is cacheable. Feeds, likes, thumbs up, thumbs down, all that fun stuff is not necessarily able to. And things that need to be globally consistent might not be. But videos and static content, obviously. So this slide basically talks to the ability to limit who can access the data, meaning that typically, or in some circumstances, some form of access control needs to be put into place that can be sometimes used for the BGP feed, will be used to dynamically ACL who can actually, because effectively you're trying to not serve wrong markets or wrong networks from those caches, so you can have some level of access control. Now, the other thing that's changed in the years that we've looked at this data, when we first started seeing service, even prior to my time at Kentik, when we first started seeing these embedded caches get deployed, sometimes they were getting deployed in service provider networks at sort of like the major metro region, meaning like the NFL city. They might be an edge location, it might be a core location. They were able to concentrate into a single data center a bunch of caches that can feed that individual market. But over time, that became problematic, and they realized that they still, every additional 10 gig of traffic or gig of traffic that comes off of those caches, they still have to build down into the metro. So you have every gig you have to update handfuls of router ports and transport and so forth. So over time it became really imperative, as the total number of CDN delivered traffic to the eyeballs grew and grew and grew, the need to push these caches down into further and further down into the market became a lot more necessary. So nowadays, we're seeing these caches get pushed down to, in a cable network, get pushed down to the CMTS aggregation level or, DSL aggregation level. Now that causes some issues there in itself too, because now you have, rather than a fewer big locations, you have a lot more tiny locations, a lot more locations to manage. Maybe you weren't collecting flow data off of those aggregation sites, so now you have to start collecting flow data. Talk to us if you want to do that. But it creates other management problems. So the trend, the result of that is that you end up having a lot more efficiency in terms of how you build a network, but it definitely is problematic. And that is a fairly major change over the last time this data was presented. Now, we had something interesting happen in the North American market over the last year or so. Amazon Prime Video, not Amazon Web Services, Sean, if you're in the audience, I remembered. Amazon Prime Video signed the deal to stream Thursday Night Football for the NFL. That created the need to produce a lot of capacity very quickly. And Amazon team was able to start deploying an embedded cache product of their own out into the network. Luckily for us, we were able to see that on a small number of customers. So I've anonymized this data here, but this is an example of the type of traffic levels that we were seeing, or how much additional traffic it is over Prime Video over that period of time. So you can see the green is all of Amazon Prime Video. The spikes are obviously Thursday Night Football. This is from sort of mid-December timeframe. As a funny little side note, you can see that the peaks decrease week over week. This is just a small snapshot. This is an interesting side effect that we noticed, that this particular provider was in a region of the country, and the second and third weeks, the Thursday night games were not local teams that they cared about, so the viewership maybe dropped slightly for those other weeks. But over the course of the entire season, it was roughly the same. So it was interesting to see a live event and be able to catch this as it was happening. Now, if we look specifically at the OTT service Prime Video and compare it or break it out by what's coming directly off the embedded cache itself versus what's coming off net, you can see the vast majority of this is definitely still coming in directly from the cache, with a smaller percentage coming in from off net, peering in transit and whatever IX ports. If we kind of drill into that and look a little closer, again, a lot of it coming from the cache directly, some of it coming over private peering and sort of a trickle coming in over the IX. And if we then break down that external private peering and IX traffic and break it up by source CDN, in this particular case, Amazon CloudFront was, still providing the vast majority of that, and some of this other stuff, smaller CDN sources provider there. Now, this is one particular example in one particular network. This is not exactly, these providers weren't consistently seen across the entire day. This is just one measurement, one place and one night. So it's not necessarily representative of all Prime Video, how it's delivered. In fact, we know it's not. We know that the other major CDN vendors were all involved with this, but this particular market happened to be this particular set of CDNs. And so kind of getting close to wrapping here, what about the hardware? What's changed over the course of the last 12 years? I think Moore's Law has been doing well for the most part. I think Nina's comments were that originally the servers that were being put in were being aggregated, so the bigger boxes required more power. And nowadays, of course, if anyone's seen the publication that Netflix has put out on how much they can get out of an amazingly tiny, small cache, it's incredible to see how the gains have been made there. So, is it easier now? So you tell us, but we think, obviously 2012 huge boxes, offload somewhat underpredictable, a little bit of, each situation a snowflake. When this was happening early on, automation was a thing, but it wasn't completely a thing, so there was still some unique corner cases. And CGN support was iffy. So now, in 2023, much smaller boxes, more predictable offload, much more flexibility, more players, and CGN support is getting better sometimes. So, what are you guys seeing? Is this accurate? Are you seeing different things? I guess this is at the Q&A section here, so I think that's kind of where we wrap. Happy to take questions. Also tomatoes, anyone seeing wrong data here? Okay, great. I will be around all week, so if anyone wants to talk offline.
Nothing, Fergus? We're good?
Sweet.
Thank you, Steve, again.
Awesome, thank you.